The history of astronomy since Copernicus has continually displaced us in centrality in the universe. We orbit a typical star in a typical region of a galaxy, the Milky Way, that is one of many spirals in a universe filled with galaxies. Perhaps the final stage in the Copernican revolution would be the demonstration that the biology that exists on this planet is not unique. That is one of the frontiers of astronomy. Astrobiology is a subject that seeks to explain life in the universe, project and predict whether it will exist elsewhere, and seek to search for it. We start the last section of Astronomy, State of the Art, by looking at life on Earth, its full range. Life on Earth is one thing. All living creatures, from the smallest microorganism to the largest mammals, are built from the same genetic code, the same genetic material, and they had their origin in a tree of life that started 4 billion years ago. Our expectations for life beyond Earth are framed by the boundaries of life on this planet. And in terms of microorganisms, those bounds are extraordinary. There are microorganisms that can thrive below the freezing point of water and above its boiling point. They can exist in toxic environments that would kill us, and intense radiation fields that would also be fatal to humans. They can exist in near vacuum. Microorganisms have proliferated through this planet, occupying almost every evolutionary and ecological niche imaginable. And that frames our expectation for what we might find in other physical environments in the solar system and beyond. Another important part of the search for life in the universe is an understanding of how life started on Earth. If life was a fluke, then perhaps life is exceptionally rare. Perhaps we are unique. But if life starts naturally, given the right chemical ingredients and physical conditions, we might expect to find biology on many of the habitable planets projected from studies of nearby stars and their planets. Unfortunately, the origin of life is historical science. The Earth is a restless planet, and evidence of life's first start may be hidden from us by the destruction of rocks from over 4 billion years old and the intense geological activity of the Earth. In terms of simple and complex organisms, we also need to know about how life evolved on Earth. Is the development of complex creatures with brains and sentience a rare occurrence or a fluke? Or does it happen naturally, given enough time? In a sense, we're asking, is Darwinian natural selection a universal phenomenon as well? If we imagine intelligent life elsewhere, it may be so strange as to be unrecognizable. But it's also worth remembering that we share this planet with creatures that are intelligent, who we do not understand, and with whom we cannot communicate. In exobiology, we must learn as much as we can from the Earth before we project outwards the expectations of life in the universe. Astronomers will continue looking at the habitable planets and try to detect biomarkers, which will be evidence for microbial organisms. Meanwhile, a separate activity called the Search for Extraterrestrial Intelligence, or SETI, has been operating for over a half-century, listening for intelligence signals from civilizations far off in space. Most of this work was done at radio wavelengths, but recently has been extended to optical wavelengths as well. So far, the researchers have been met by what's called the Great Silence, but they're not discouraged and think only now is the search getting interesting. Life in the universe requires us to think out of the box. Since all biology on the Earth is an example of one thing, and we have no general theory of biology, we don't know how strange life or intelligence might be in far-off realms. But the sheer abundance of habitable sites in the Milky Way and beyond leads to a statistical expectation that we are not alone in the universe.